So my mom ditched me today. She wasn't feeling up to having a visit, so I have a bunch of time. So let's do some Supercollider this stuff. So here we are, booted up Supercollider. I know this is very fast and I'm like that. So Supercollider, we booted it up. And actually I'm going to reboot. So go to server. Let's quit server because I've got a load of these oscillators working, 585 things, functions going, because I don't actually terminate functions. They just get quiet because I don't know how to code. So they don't have like proper stop functions or something. So I use up something, oscillator somehow. So every once in a while, I need to clear the brain so I can get it to act nice and sweet and fast again. See, this is how little I know about what I'm doing. Booting server. So this is going to be our stuff that I'm going to play with. And these are some very, very simple oscillators. Okay, let's go. Synos. One is at, oh, yeah. So I have these set at 439.99 and 440.01. Okay, and that's because I need, if we just set a straight frequency on the oscillator, then you would just get a flat line because it is actually the phase differential between the two signals on the X and Y axes, the left and right channel, which creates the rotation so that it looks cool visually. So I will demonstrate ça. Okay, so let's just do this. This is 440, and let's just make this 440, see it's 0.01. Let's just take that out for a second. Okay, so the server's working. I don't know if these died. I think these functions died. Oh shoot, so I must reboot. Okay, wait, show scope, because I want a scope. This scope. I'm gonna go in the XY plane. There we go. Okay, so now I'm gonna run 440 and 440 on the two channels as a play. Ooh, I just played it. Yeah. It says the synth is going, so let's see. Maybe it's the signal, and I'm just not hearing it. Oh, there it is. So it's okay. See, that's 440 and 440 because it's getting everything at the same time. So like when there's a voltage on one side, there's a voltage on the other. It's exactly perfectly matched. That is boring. Okay, that's boring. So instead, we're going to add just a little tiny bit of difference. They're like twins. It's like it's genetically the same, but because they grew up in a slightly different location, they're actually different people. Just that little difference could make all the difference. And there we go. See now, and that is a sine wave because it's a perfect circle. So now, see, that's what the cool thing. Okay, so that's nice, but boring. Circles are boring. So let's add another oscillator at almost the same frequency. And now we have two oscillators going at almost the same frequency. Okay, that's looking cooler. Def cooler. Let's see what we do. Oh yeah. I think this is the one we didn't play, so let's add this. Now we'll add a harmonic, another frequency to this game. Oh yeah. See, that's two sine waves. Slightly just a phase thing, so it's like a circle, but it's contorting itself. Let's scale this down a bit so we can see the whole thing. I mean, look at that. What was that? That's just like 2 or 3 oscillators, almost the same frequency. So beautiful, though. Come on. It's like orchids or something. Look at that. Bilaterally symmetrical. Almost. Almost. But not quite. Now, how you can use this for physics, that demo that I like to give kids, is where you stack up harmonics and you create a square wave out of, oh my gosh, it's beautiful. Okay, I'm gonna stop and expand out. But let's say we did something more whack though. Like instead of 439.99, that's 430.99. Because now we're gonna have a crazy difference between these two things. I mean, crazy is like 10. Wait, what? Oh, that was another one I did. What's that? Do, 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 do. Ah, where'd my code go? Get away. Okay. This is what we hate, corporations. This is what we hate, just letting you know if you didn't already. Oh, seriously? I don't want any of that, and I don't even know why you're booting up Microsoft Store. Okay, and see, that's that much variation. Yes. I think everyone should pick up Supercollider because it's fun to play with. And it will teach you all kinds of things about mathematics and relationships and harmonics. And all the math behind harmonics and how it goes into music. Which is really amazing because, I don't have it right here handy. But it's like, the 1 and the 2 and the 1.5 and the 1.25 and all the simple fractions. Hey, what's up? I don't know what this music is. Oh, this is some whack music, which I'm prone to make. the scope. What was that? Wait, I gotta get my glasses, literally. Oh, where are they? Is it possible to lower one's volume and look at the pretty pictures? Oh, okay. Huh. Really? Is that loud coming across? Gee, I have no idea. That's loud? Oh, unfortunately, it's just playing it. We're looking at what I'm playing. But before, I was just doing a little demo. Well, I have more like music-y music too. But then just for the cool graphic-y things. Ooh. See, for parties. Project that on the wall. Yeah, well, you know, I make banjo-y music. I like to make all kinds of music. Music is awesome, so I like to make all kinds of it. What was this? Here's the annoying thing that I was working on recently. See what it looks like. All curves. Yes. But mostly I was talking before about, you know, just making the cool shapes with them. Oh yeah, this is one of my faves. It's the universe slowly unfolding itself into different configurations. The universal wave function. I know, let's get the mouse on the big screen. I'm such a doofus. Trippy AF, right? It's just physics. That's the overtones. More overtones, more complexity. I mean, I guess in a way this is a Penrose psychic cosmology idea. Almost like there's two oscillators and the beat frequency gets really simple sometimes. And then it expands. It gets more complex. And reaches a certain threshold. And fades again to sublime simplicity. I could have a whole freaking channel, just this all day, right? Yeah, this is exactly what we're listening to, that hum. This is what it looks like. See, the harmonics are going down. More simple, less kinks in the wave. There it was, but now it's going up again. It's based on whatever those oscillators I set going. This is like 3 oscillators going slightly out of phase and stuff with each other. Yeah. And then it's their interaction that's causing this like swirliness. They're all out of sync, but eventually they find always in sync again. Well, let's just find a piece of music that you like. Let's like think of the problem. Let's see what this piece sounds like. Yeah, actually, if you have Supercollider, I don't use it for sampling, but it does have sampling capabilities. Yeah, there's another program actually. I mean, I love Supercollider for programming. There is this insane, amazing program that I don't have on this computer because this isn't really my computer. That what's it called? Granula. No, coagula. Coagula. COA, like coagulate. COAGULA. And what it does is it takes any bitmap and turns the bitmap into an audio file. Or you can, so what you can do is take video data that's frequency stuff like from stars or something, totally, and input that as a bitmap, and then it would play it. And the way it plays it is basically just like one of those volume screens. Like this is frequency. It's like it's based just on XY stuff. So it's like this is frequency, and then left and right was color thing, some kind of color data, and then intensity is intensity of the Fourier analysis. It's like basically like it does a crazy Fourier analysis of the bitmap, assigning the range, and you get to choose what the range is, etc. The way it's expressed. It's a super cool program. Yeah, Coagula. I don't have it on this computer. I have it on my two busted computers, but not on this one. This is a borrow. I am way computer poor right now, like hypercomputer poor. I have my iPad, which is beautiful, and I did all my original conceptualizing of neutron decay cosmology was done on this beautiful creature, and thanks to my ex-roommate Mike for giving it to me. It was awesome. But yeah, Collider's cool. Having an oscilloscope is cool. So my other favorite program is no, go away and go away, go away, and we'll close you down. Is this right here called Sin Factory. And this is a modular synthesizer program, and I was trained and raised on modular synthesizers, so I understand them really well. Oh, I probably just booted up too. And it's got a lot of functionality too, plus an oscilloscope output. So that is one of the bonuses, because it's weird, like, mostly my background is art, but I'm a huge science nerd also. It's the thing. And that's why I integrate them. That's why I've been all about STEAM for kids, where you got to mix it up. You use the art to express the knowledge, and that way it becomes culture. And come on, still booting up. There it goes. Oh yeah, see, I booted up 3 or 4. So this is also a program, and it's got oscillators, and you feed the oscillators into stuff, and you build these big machiney things, and then you play them. I make really idiosyncratic music. I think this one doesn't have X-ray. But for certain things, like I can demonstrate, what's one of my favorite things to demonstrate to kids is like how to build a square wave. How you build a square wave out of signs is part of Fourier. It's full of weird purry. Yeah. But this is really powerful too. And really, I mean, people don't think about it. But like right here, what I built here is performing an extremely complicated calculation right now called this music. You know, like this is all just oscillators feeding back. There's no sequencer in here. There's no programming as such. This is just counters and oscillators and potentiometers. Like it's all really some delay mechanisms, but all very analog computer. Basically, that's what this is. This is an analog computer that I programmed to make this piece of music. If you call it that. Let's find something else to play because I don't know. I just make shit up. I have thousands of things. See, that's crazy. There's no sequencer in there. I just pick a bunch of. How it even runs itself out. I built it so it would stop itself after a certain amount of repetitions because it's got a built-in counter. So you can just use it for a sample and then you could sample it afterwards, right? So it would be like, oop. See, it only play after a certain 32 repetitions someplace. Yeah, I mean, really, it's an analog computer, or it's a digital construction of an analog computer, which is even more bizarre. But such is the world we live in. Okay. This started out shorter, and now it's turned into very, very, very long, and we're a half an hour in. This is crazy. I never do this kind of thing. But as I said, oh yeah, this is my new sweet song. Can you feel life beyond the stars as they shine down their love? Yep. Yeah, super useful though. It can do graphics too, and I just haven't learned how to do the graphics on it. Everything is so powerful. Okay, peace out, anybody that ever watches this, ever.